This is Hunter, and I'm making a video on 1C, or converting decimal to binary, and vice versa. So here's an example, 41 decimal. I'm going to put this into a table. (41) divided by 2 is 20. The 0.5 times 2 is a 1. Divided by 20, or divided by 2. Oops. 20 divided by 2. That's 10 with a remainder of 0. 10 divided by 2. That's 5 with a remainder of 0. 5 divided by 2 is 2, the remainder of 1. 2 divided by 2 is 1 with a remainder of 0. And 1 divided by 1 is 1, remainder 0. Or, sorry, 1 divided by 2 is 1, 0. That means we can write it out like this: 1 0 0 1 0 1, and that should be the right answer for 41 in binary. Now, 83 decimal to hex. We do the same thing. 83 divided by 16 is 5, with a remainder of 0.1875. Multiply that by 16 with a remainder of 3. And now 5 is just 5 divided by 16 is a remainder of 5. So that means it is just 5 3. And now for a decimal, we can go 80.81 times 2. There's a 1, so we do that. 0.62 times 2, there's also 1. 0.24 times 2, there's a 0. 0.48 times 2, also a 0. 0.96 times 2, it's a 1. 0.92. 0.92 times 2, it's a 1. How many digits? Let's get this to 8 digits. 0.84 times 2, that's a 1. 68. Okay, this is the last one. Oops. Which is a 1. And now this is the most significant bit and the least significant bit. So it's going to be 0.11001111. And this probably isn't a perfect conversion, as it can't really be a one-to-one conversion. But this is probably a pretty good approximation of 0.81. Now we're on to the next page, which has a pretty big number, 479. 479 divided by 8. 59. Take the 0.875 times 8. 7. 59 divided by 8. That's 7. Take the 0.375 times 8. It's 3. 7 divided by 8. Multiply it by 8. 7. And this one happens to be a palindrome, so you don't even have to worry about which way to write it. So there's 479 base 10 in octal. Okay, we're going to start with this next problem. And we're going to do this by doing the power 2 to the power 0, 2 to the power 1, 2 to the power 2, or 1, 2, 4, 8, 16, 32, 64. How many digits do we have here? 1, 2, 3, 4, 5, 6, 7, 8. 8 digits. So we have 1, 2, 3, 4, 5, 6, 7. Okay, so we have a 128. So 128 plus, we don't have a 64. We don't have a 32. We have a 16. We don't have an 8. We have a 4. We don't have a 2, and we have a 1. So you can add these all up. That's going to equal 149. Okay, and now we're going to move on to converting this base 16 number into a base 10. And I'm going to do this by using the sum of weights. So it's going to be 7 times 16 to the 2 plus F times 16 to the first plus E times 16 to the 0th. And we can put this in our calculator. 7 times 16 to the power of 2 plus F, which is 15. So that means we have to put 15 in. 15 times 16 to the power of 1 plus E, which is 14 times 16 to the power of 0, which all equals 2046 in base 10. And this concludes my demo video. Thank you for watching.